Hello, how you guys doing? Today we're going to learn more about exponents. As a quick reminder, remember that exponents means the base times itself that many times. So like for this example, it says 2 squared. What that means is it's 2 times 2. If I had an example of x to the fourth power, that would equal the same as x times x times x times x. So the exponent tells us how many times that base will be multiplied by itself. Today we're going to be talking about multiplying exponents, where we have the same base and we're multiplying it by something else with the same base, but with exponents. So this one is x to the third times x to the fourth. So we know x to the third means that it's x times x times x. There's 3 x's, right? And we have times x to the fourth. That means that there's 4 x's. 1, 2, 3, 4. So how many total x's do we have? We have 7. So that gives us x to the 7th. There's a way to simplify this or make it easier is when you multiply exponents, or multiply exponents when they have the same base, so x to the third times x to the fourth, we can add the exponents. 3 plus 4, and that gives us x to the 7th. So when we're multiplying like bases, we keep the base the same and we add the exponents. Alright, let's try some examples here. So this first one here says simplify 5 to the third times 5 to the fourth. So I know that 5 to the third means that there's going to be 5 multiplied by itself 3 times. So 5 times 5 times 5. And then I also have 5 to the fourth, which I know it will be 5 times 5 times 5 times 5. 5 to the fourth. So 5 to the third means I have 3 5s times each other, and 5 to the fourth means I have 4 5s times each other. And that's going to give me 5 to the 7th, because there's 7 5s. We have 1, 2, 3, 4, 5, 6, 7. 5 to the 7th. We can do the same thing with exponents. So this exponent here, or sorry, with the variables, not exponents. So this is w to the third power. So I know w to the third power means that it's going to be w times w times w. We have 3 w's multiplied by themselves. And then w to the fifth power means that will be 5 more w's. And that's going to equal, we spread it out, and we can see now that we have 1, 2, 3, 4, 5, 6, 7, 8 w's. So it'll be w to the 8th power. Pause the video and try number 3 on your own. Alright, in our next example, we have 2 times x squared times 3 times x to the third power. So we can expand this out as well. So that means 2, this one here, 2 times x squared means x times x. And then we have 3, so times 3 times x to the third means x times x times x. So now I can simplify. I can see I have 2 numbers. I have a 2 and a 3. And I know 2 times 3 will give me 6. Now I can simplify my x's. I have to count how many total x's I have. I have 1, 2, 3, 4, 5. So that gives me 6 times x to the 5th power. And if we go back to our rule, we can see that x squared times x to the 3rd power, if we add those two, that will give us x to the 5th. This next example looks big and long and complicated, but it's really not if we expand it out. We can see pretty easily what it's going to be. So I'm going to take my first term here, and that's 2 times s squared times t. So 2 times s times t. My next term, I have negative 3 times s to the 4th. So that would be times negative 3 times s times s times s times s. And now my last term, I have 7 times t to the third. So I know that means 7, and then times, and then 3 t's. T times t times t. And now I can simplify it and figure out what my answer is going to be. I can start with my numbers. I see I have 2 times negative 3 times 7. And that's going to give me negative 42. Because I can times those are just numbers. Next, I'm going to figure out how many of my variables I have. So I have s times s, so I can figure out how many s's I have total. So I see I have 1, 2, 3, 4, 5, 6 s's. So it'd be negative 42 s to the 6th power. And then I can do the same thing for my t's. How many t's do I have? I have 1, 2, 3, 4. So that'd be t to the 4th power. So that big long expression over here looks big and complicated, but really when we expand it out, we can see all we do is multiply the numbers and then add up how many s's we had and how many t's we had, and those become our exponents. In our next example, it says simplify it using the rule only. So we know the rule is if we have the same base, so on this one we have x to the n, and this one we have x to the m. If we have the same base, we can just add our exponents, and that will give us our simplified exponent. So in this example, we have w33 times w41. So I can see I have the same base, so that base is going to stay the same. And if I'm using my rule, that means I can add my 2 exponents. So my first exponent was 33, my second exponent is 41. I can add those 2 together and get my simplified exponent. So that would leave me with w to the 74th power, because 33 plus 41 equals 74. In our next example, it says simplify it using the rule only. So I can see that I have 3 times 2. So those are numbers, so I can just put those there. But they're both being multiplied by the same base of g. So I have to put times g. And now using my rule, I know that I can add these 2 exponents together to get my final exponent. So my first exponent there is 3, and my second exponent is 10. So 3 plus 10. And when I simplify it, I can do 3 times 2, which gives me 6. And then now I can add my exponents, which will give me the base of g, and 3 plus 10 is 13. Alright, go ahead and pause the video and choose either the odd numbers or the even numbers to complete on the next page. Unpause when you're done. If you need help, feel free to ask me any questions. Alright, the next thing we have to learn is called power of a power. So that means when we have an exponent, like this x to the 4th, is also raised to this 3rd power. So how do we do that? So what that means is this x to the 4th is repeated 3 times. So we have x to the 4th times x to the 4th times x to the 4th. And what that really means is this first x to the 4th means that there's 4 x's. X times x times x times x. And then the next x to the 4th means there's 4 more x's. X times x times x times x times x. And then this last x to the 4th also means that there's 4 x's. X times x times x times x times x. So we have all these x's, and now we can simplify it. Now we can add up all of our x's and see how many total we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be x to the 12th power. Pause the video and try example 2 on your own. Expand it out and see how many t's there are. Unpause when you are finished. Alright, example 3, we have x times y in parentheses raised to the 4th power. So what that means is that x times y in parentheses is being multiplied by itself 4 times. So we have 1 group, 2 group, 3 group, and 4 groups. It's showing up 4 times. There's no other exponents in here, so we can go ahead and simplify it. We can add up how many x's we have. And I can see here I have 4 x's. And I can add up how many y's. And I can see that I have 4 y's. So if I simplify that, it would be x to the 4th, y to the 4th. Alright, in example number 4, we have 3x squared in parentheses raised to the 3rd power. So that means that 3x squared is going to show up 3 times. So we have 3x squared once, 3x squared twice, 3x squared 3 times. And we know that 3x squared, we can expand it out, means 3 times x, because x squared means x times x. And then we also have that again, 3x squared, so 3 times x. And we have it one more time, 3 times x. Alright, just like how we simplified the others, I see I have numbers, these 3 times 3 times 3. I can combine those, and that would equal 27. 3 times 3 is 9, 9 times 3 is 27. And then I can add up all my x's. I have 1, 2, 3, 4, 5, 6 x's. So that would leave me x to the 6th power. So I have 27 times x to the 6th power. Now you're probably thinking to yourself, there's got to be an easier way than spreading all this out and expanding it out each time. And there is. And what's happening here is this 3, this exponent 3, is being distributed to both of these things on the inside. So we have 3 to the 3rd power. 3 to the 3rd power equals 27, which is what we got for our answer up here. And now we have 3, or x squared to the 3rd power. So when you have a power raised to a power, what you do is you multiply those two. So what really this is x to the 2nd times 3, and that will give us x to the 6th, and that's what we got for our final answer over here. So that's the easier way to do it, is when you have a power raised to another power, you multiply those two exponents. Now that I know that, we can simplify this a lot faster. This 3 gets distributed to everything inside those parentheses. So I have negative 5 to the 3rd power. Negative 5 to the 3rd power, I know, is negative 125. I also have x to the 3rd raised to the 3rd power. So that means I can multiply those two exponents. And that's going to leave me with x to the 9th power, because 3 times 3 is 9. Now that you know this, pause the video and try example 6 on your own. Alright, this is what you should have got. So we have 3 to the 5th power raised to the 2nd power. That gets distributed to it. So that means we can multiply those two and we get 3 to the 10th power. 3 to the 10th power, 3 is just a number, so we can simplify that by actually doing it. 3 to the 10th number, to the 10th power is 3 times 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 3, which is a huge number. And we get 59,049. And we also have x to the 3rd power raised to the 2nd power. So we can multiply those exponents here. 3 times 2 is 6, so that gives us x to the 6th. Since we don't know what x is, we just bring that over, and that just stays x to the 6th power. So our final answer is 59,049 times x to the 6th power. So what's the pattern? The rule is when you raise a power to an exponent, you have an exponent raised to another exponent, you multiply the exponents. Alright, that's all the multiplication properties of exponents. On the next page, I want you to try either the odd or the even numbers. I don't care which ones you choose which ones you want to do. When you're done, get it checked by me. And then after that, you can work on the classwork and then the homework. See you later.